A rigid architectural scaffold manages a continuous flow of luminous particles. This highlights the relationship between static infrastructure and the transient items moving inside it. SQL functions across two separate layers, categorized by whether a command alters the container or contents. A 3D wireframe grid forms an empty database table, the structural container. Beside it, solid blocks represent the data. Architecting this wireframe uses Data Definition Language, or DDL. Manipulating the data blocks inside uses Data Manipulation Language, or DML. These two languages operate under a strict chronological dependency. You must define a structural container before you can manage any state. The grid has to exist before the blocks can be placed. Classifying a SQL command relies entirely on identifying its target. Evaluate whether the command modifies the architecture of the table itself or the records stored within it, ignoring what the code output looks like. Distinguishing between schema design and record processing allows for precise control over how information is stored and accessed. We can observe the exact impact of structural commands by building a new relational book table from an entirely blank system. The create table command initializes the system, transforming into an empty 3D wireframe grid that defines parameters for book ID, title, author, and in stock. This DDL blueprint dictates field names and data types. Notice this foundational action adds 0 records. It only erects the scaffolding. If the design needs to evolve, we use the alter table command to modify this existing schematic blueprint. Running an alter command appends a new column directly to the wireframe, expanding the structure's capacity to accept new types of data. There are also destructive structural commands. Drop table dismantles and destroys the entire schema completely. Truncate acts as a rapid reset, clearing out all records but preserving the wireframe itself. Because the container's design dictates field names and data types, these structural choices govern every query and form created later. With the container established, we shift to the operational phase. We must now use DML to interact with our newly created empty table. Here we see the insert into command. It takes raw values and packages them into a new record, filling the first horizontal row of the grid. The insert statement successfully populates the container, but it leaves the blueprint and constraints completely unaltered. The update command modifies a record. It targets an existing row to change a specific value, like shifting a stock status from true to false, while the wireframe remains static. Then, the delete command removes a specific data block, leaving an empty slot. Finally, the select command acts as the reading mechanism. It retrieves and views these data blocks, allowing users to query the table without modifying either the structure or the state. DML tools are inherently constrained. They work entirely inside an existing structure, managing transient contents while leaving the architectural blueprint intact. In a live, everyday database environment, the execution frequency of DML and DDL looks entirely different. Operational systems rely on DML for nearly all user-facing tasks, executing thousands of times per minute to retrieve or update individual rows. DDL commands are executed rarely. You typically only see them during the initial design phase or during major planned systemic overhauls. This operational divide helps clear up a common misconception, the assumption that create table belongs in the DML category because it adds something to the database. Create table initializes the structural capacity to hold data. It does not inject data itself. Because its target is the architecture, it is strictly DDL. A second misconception surrounds the select command, which is sometimes isolated into its own category called Data Query Language, or DQL, in certain textbooks. Because select interacts directly with stored rows and relies on their state, standard operational syllabi group it firmly with DML. It targets the records, not the schema. Avoiding professional errors requires ignoring what a command seems to output. You must strictly analyze whether its underlying function targets the container or the contents. We can categorize any SQL command using a strict binary filter. Just ask, does this statement change the table design, or does it change the rows? This diagram illustrates the sorting process. Commands that alter the design, like alter, drop, truncate, and create, fall straight into the DDL bucket, highlighting the schema. Operational commands that target the rows, like insert, update, delete, and select, fall into the DML bucket, manipulating the data blocks. In professional environments and exams, phrasing like define data structures or add a new field maps directly to DDL actions. Conversely, phrasing like manipulate data or insert new records maps directly to DML actions. This brings us back to the chronological rule that governs all relational databases. Structure must always precede state. You cannot manipulate records that do not have a defined schematic home. DDL architects the database. DML manages the data. Mastering this exact division allows complex data systems to scale reliably without collapsing.